something that might surprise you. The F-35 Lightning II is not the fastest aircraft in the world. It is not the most maneuverable either. There are older aircraft that can turn tighter. There are more affordable aircraft that can fly faster. So, why is the F-35 considered one of the most advanced aircraft ever built? The answer has very little to do with speed, and almost everything to do with something far more powerful. Let's take a closer look. The F-35 Lightning II is a fifth-generation multi-role aircraft developed by Lockheed Martin. It first took to the skies in 2006, and today it operates from runways and ships across the globe. But unlike many aircraft that came before it, the F-35 was not designed to focus only on speed or maneuverability. Instead, engineers approached the challenge from a different angle. What if an aircraft could detect information earlier than anything else around it? What if it could process more data in 1 second than older systems could handle in 1 minute? And what if it could share that information instantly with other platforms? That idea changed everything. Modern aviation is no longer just about how fast something can move. It's about how effectively it can observe, understand, and respond. And in that environment, the F-35 stands out. To understand the F-35, we first need to understand low observability, often referred to as stealth. This isn't about invisibility in the traditional sense. It's about reducing how detectable an object is to systems like radar. Here's a simple way to think about it. A radar system sends out a signal. That signal travels through the air until it reaches an object. When it does, part of that signal reflects back. The stronger the reflection, the easier it is to detect. Traditional aircraft tend to reflect a significant amount of that energy. Their shapes and surfaces allow signals to bounce directly back to the source. But the F-35 is different. Its design carefully controls how those signals interact with the aircraft. First, the shape. Every edge and surface is aligned in a way that directs incoming signals away from their source rather than back toward it. Second, the materials. The aircraft uses specialized composites that absorb portions of that energy and convert it into small amounts of heat. The result is a dramatically reduced radar signature. This allows the aircraft to operate in complex environments with a much lower chance of being clearly detected. But this is only one part of what makes it unique. Now we move to what truly sets the F-35 apart: its awareness of the environment. The aircraft is equipped with a system known as the Distributed Aperture System, or DAS. 6 infrared cameras are placed around the aircraft, creating a complete 360-degree view of the surrounding space. These cameras work together as a single system, and here's where it becomes remarkable. That visual information is streamed directly to the pilot's helmet. The helmet acts as a display, projecting key flight data and sensor information directly onto the visor. Everything is aligned with the pilot's line of sight, so wherever the pilot looks, relevant information appears naturally in view. But there's more. Because the helmet is connected to the external cameras, the pilot can effectively see in every direction, including below and behind the aircraft. Looking down reveals the terrain beneath. Looking behind shows what is outside the field of view of the cockpit. This creates an entirely new level of situational awareness. It allows the pilot to understand the environment instantly, without needing to rely on multiple separate displays. And beyond visual systems, the aircraft also uses advanced radar and optical sensors to gather additional data across long distances and in various conditions. So, the pilot is not just seeing more, they're seeing smarter. Now comes the most important part. All of this information needs to be processed. In older aircraft, different systems present separate streams of data. The pilot must interpret each one and combine them mentally. That takes time and effort. The F-35 approaches this differently. It uses something called sensor fusion. Data from cameras, radar, and other systems is combined into a single, clear picture. Instead of raw signals, the pilot sees organized, meaningful information. Objects are identified, tracked, and displayed with context. This reduces workload and allows faster decision-making. But the system goes even further. The F-35 can share this information with other aircraft, ships, and ground systems. This creates a connected network where information flows between platforms. One aircraft can observe something and instantly share that insight with others. This means that even systems without advanced sensors can benefit from the F-35's awareness. In this way, the aircraft becomes more than just a standalone machine. It becomes part of a larger information system. And in modern aviation, information is one of the most valuable advantages. The F-35 was designed to be adaptable. There are 3 main versions. The F-35A operates from standard runways. The F-35B can take off from shorter distances and land vertically, allowing it to operate from smaller ships or limited spaces. And the F-35C is optimized for aircraft carrier operations. This flexibility allows the same core platform to be used in a wide range of environments. It can support different types of missions, from observation and monitoring to coordination and support roles. And because it shares data so effectively, it enhances the capabilities of other systems operating alongside it. This is one of the main reasons it has been adopted by multiple countries around the world. It is not just about performance, it is about integration. So let's return to the original question. Why is the F-35 considered one of the most advanced aircraft in the world? Not because it is the fastest, not because it turns the tightest, but because it represents a new way of thinking. It is designed to observe, process, and share information at an unprecedented level. Its shape reduces detection. Its sensors provide full awareness. Its systems organize complex data into something simple and usable. And together, these elements create something entirely new. An aircraft built not just for movement, but for understanding. If you enjoyed this breakdown of advanced aviation technology, consider subscribing for more deep dives into engineering and innovation. Thanks for watching.